the second phase of your project. So if you, even though you couldn't finish your phase 2, you should submit to avoid the late penalty. Then you may have a couple of more days to revise and complete your project. Then resubmit. When you resubmit it, you can inform to GA. So GA and me will be generous for such a resubmission. Otherwise, if you just wait until you complete everything, then you resubmit next week. Probably you will get the late penalty to be fair with the other teams who submit on time. Okay? Then you don't have to include the relational algebra in your project. Instead, you should include up to the normalization process. Also, phase and phase 2 that you complete so far should be presented in the next week interim presentation. It will be the Tuesday. Okay, so it's not a formal presentation. However, you need to prepare the PPT file no more than 10 minutes, which means I think the 7 or 8 slides, including title, will be enough. In your presentation, I'm expecting the overview of your project and what is the objective and what other functionalities that you are going to implement in this project, as well as your overall configuration. For example, we are going to use a C#.NET to implement a web-based interface. At the time, probably I'm curious what web server are you going to use, or standalone system. So is it a two-tier connection, whatever. But database backend should be Oracle Database 10G at UB. Okay, so it's a common thing. So we are going to use the same database that we are going to learn in the second half of the semester. Okay, so which means you don't have to download the Oracle database full package and install. No, you don't have to do that. Just use. Right now, so far, you don't need create a physical database because we didn't cover yet. Okay, and also after interim presentation, you will have the midterm exam. Midterm exam will cover up to the normalization. Not this part. This part will be the second half, which means the final exam. In your exam, you will get the half of the multiple choice. The other half will be descriptive question, like the throw the ER diagram or the relational schema diagram, as whatsoever. Okay. Any questions so far? Okay, so who will, yes.
Resubmission doesn't deduct the marks.
Which is submission?
For the
Resubmission, yes. That's what I'm saying.
Doesn't deduct any marks.
No.
When it will be the exam, the midterm?
When? It's a Thursday in the classroom. Yes. Exactly 1 week later, right? This time, this classroom, so you will have the midterm exam. Okay? So if you are coming from the morning class, you should take the exam in the morning, because morning and afternoon will be different exam. Any other question? Okay. Then so far we are doing the relational algebra and the calculus. So what is the main purpose of the relational algebra and calculus? So what is the purpose? Usually at the beginning of the course, at the beginning of the chapter, I'm asking the student what is the main object, why we are doing this kind of thing, why we are learning the relational algebra and calculus.
I think it's for the presenting the output relational algebra, the output of the database.
Output of database? What kind of output? Output of what?
Of questions, of queries.
Question, query. So after you build a house, you should know how to use that house, how to access the house. It's exactly the same thing. After you build a database, you should know how to use the data, how to access the data. And relational algebra and calculus show the way to access the database. Okay? Since our database model is based on the what? Relation. That really. So we need some operation to access the data. Just like the natural number, 1, 2, n. 1, 2, 3, 4, 5, 6, n. What kind of operation are you using? Plus, minus, multiplication, division. Sometimes you can define your own operation, right? relation is a set. We need some operation to handle, to manage, to access the data. That is called relational operation. Okay, using the relational operation, we can handle, access the data. So first we learn what? Selection. Selection is to specify the tuples, the data, by giving the condition. Like the I want to retrieve employees whose salary is bigger than 30K. Bigger than 30K is the condition, so we can use the select operation. Because the accessing relation by tuple, by data, by row is one way. Another way is through attribute. So you can specify I need only first name, last name, and middle name initial for employee. At that time, you can use which operation? Selection, then projection. So you can use the project operation to specify the tuple. Also, keep in mind, input and output of any relational operations are what? Relation also. So we can use the output of relational operation for what? Also input of another relational operation. Then we can make what? Relational expression. So definitely when we access the data, relational data, for example SQL, that language, that relational algebra will not be very simple. You need bunch of different ways to access very complicated data. Why? Because we normalize. Your data is just one bin, one group? No. It's in the relation, other table, many tables. Your information are scattered all around in your database. So you need to access this one. At that time, you need this operation at the same time. That means it's a relational expression. How can you make it? Because output of one operation will be input of another operation. So then, also I don't like the first name. Instead, I like the name. How can you change the name of attribute? Rename operation, which is called a row. Using row, you can change the name of the attribute. Also, output of the relational operation is also relation. I try to make the simple name for that output. How can you make the rename of relation? Arrow. Using arrow, you can rename like the result or R1, R2. Okay, that is the thing that we discussed the last class. Then today we are going to learn the more relational operation. Okay, so this is the example of the rename. You can rename F name to first name, or last name to last name, L name to last name, and so on. The next one is the set operation. What is the basic of the relation? What is it actually? What is the relation? It's a set. Okay? That means, can we use any set operation in relation? Why not? Because a set is a relation. Relation is a set. So we can use set operation.
You have to have the same meaning. One meaning.
What does that mean? One meaning?
One meaning. That the attributes in one relation should be...
I'm asking the set operation. What kind of set operation did you learn in your elementary school? You can union, two set. You can intersection, two set. You can minus, two set. Can you remember that? That is a set operation. That is the operation to handle the set. Can we use such a set operation in relation?
Of course.
Definitely yes. So we can use such a set operation, union, intersection, minus in our relational model. However, that set operation are different from selection, projection, and rename. What's the difference? They are applied to one relation. It's called a unary operation. On the other hand, set operations we need two relation. Union we can union combine two relation, two set. We can take out the common thing, intersection, from two relation. Minus definitely two relations. So they are called binary relation. First, union operation. So union operation, what does that mean, union? Common thing here and here. Not common thing, at least belongs to one of them. So we can combine. So in this case, we have 1, 2, 3, 4, 5, 6, 7 tuples. Then 1, 2, 3, 4, 5. 7 plus 5, we can combine, union. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not 12. Why?
There is common.
There are common things, duplicate data. So when you union, when you combine, you need to take out, you need to remove any redundant information. That is the reason we have only 10 of them. That's the only thing you should be careful. One more thing actually. This is a student relation, first name and last name. This is an instructor. Somebody may be curious. They are different. How can we combine two different things? So can we union social security number and first name? No, definitely not. They are totally different. So can we union student, FN, LN, instructors, first name and last name? Can we do that? So when you are doing set operation, union, intersection, minus, their types should be the same or comparable. Which means actually the meaning of this one is the same of this. So we can say that it's a time comparability. So when you are doing the set operation, the type should be comparable. That doesn't mean the name should be the same. It's not important to name. Sometimes it can be FN, it can be F name. Names are different, but their type exactly. That means domain. So domains are the same. Okay, can you remember the domain in relational model? Domain is almost the same as what? Data type, but a little bit different. It's kind of pool of the data. Their pool of data is the same as this one. So at that time, we can union, intersect, and minus. Okay, name is not very important when you are doing the set operation. The data type or data domains are same one. You need to check. They should be the same. Okay, in this case, it's the first name. Both of them are the name, so we can combine. Then what about the minus? Minus means it belongs to the left-hand side, but not in right-hand side. So we can take out the common thing from left-hand side. That is, at that time you don't have to worry about the duplicate, right? Because it's already unique. Okay, there is no redundant information. If you take out something from existing one, definitely it's there. It's a it should be intersect, right? It's not the union, it's a mistake. So it should be intersect. Intersect means common tuples, common data, both sides. Yes?
What's the minus here?
Minus is a minus. You can take out the tuple from instructor. Take out, subtract the student. That is a minus. I probably you learned in your math class. Minus operation, right? So let's say the example. So we have two sets. A, B, 2, 3. What is A minus B? 1. This one. It's the same thing. So from instructor, you can subtract the student tuple.
So they will put the unique tuples.
They are unique.
But in the union, there were only 10 tuples.
Yes.
And the duplicate was gone.
Yes.
So it means like there are these are the uniques. What about the others?
The other, what is the others?
If we just go back to the union, please, sir.
Yes, this is a union.
So it should be.
So why don't you take a look at this one? Union means, what is the union of A and B?
1, 2, 3.
What is the union?
1, 2, 3.
1, 2, 3. It's not 1, 2, 2, 3.
No.
No. Same thing. What about the intersection of this one?
2.
2. That is the next page. This is the intersection. Common thing. What is A minus B here?
1.
A minus B. 1.
1.
That is this one. Okay? I think. Yes. So intersection. One more thing. Sometimes in real life system, the Oracle Informatics DB to real DBMS system, the user of such a commercial DBMS request, I'd like to retrieve the union, including duplicate data, okay, for specific reason. So they asked a lot. So there is another set operation that is called union OR. Union OR return A and B, including duplicate data. Okay? So in terms of the relational model, this is not allowed. However, in commercial software, DBMS system, they allow sometimes duplicate data. This is additional function. So don't be confused when you are using the relational DBMS system. They support such a return duplicate data. Okay? Difference we already done. Definitely. You cannot change the order of minus. It's not commutative. Okay? Then one more thing, the binary operation. In this case, have you ever learned about this operation in your math?
Yes.
What is it called? What is the return of this one?
Product.
1, 1, 1, 2, 1, 3, 2, 2, 2, 3.
Product.
This one, this one, this one, this one. Yes. Right? What is this?
Product.
Product, especially
Product of product.
Cartesian product. This is called the Cartesian product. So this is another set operation. Cartesian product. What is a Cartesian product? It's each and every combination of elements. Why don't we change the Cartesian product into relational model? It's each and every combination of what? Tuples from two relations. Okay, for example, here we first, why don't you take a look at this one, employee names. We have female employee names. That is this one. Female employees name, Elisa, Jennifer, and Joyce. Okay? Elisa, Jennifer, and Joyce. So we have female employees name over here. Then we have another relation that is not mentioned. That is dependent. Can you remember the company relational database schema? We have a dependent. Dependent, it has employee social security number as well as the dependent name as the primary key because it's a weak entity. Okay, then it has the sex and birthday and so on. How many tuples we have? 7 of them. 7 dependents are independent. This relation. So we have female employee. That small relation, small table. So can we make female employee product, Cartesian product with dependent? Cartesian product. Can we do that? Yes.
Yeah.
Not a problem. So each and every combination, which means we regard each tuple as the element. Just like the first, combine tuples attribute in left hand side. Female employee name. Okay, that is first name, last name, social security. Another part is this one, dependent, attribute in dependent. Then create, merge two tuples. ELISA, for each ELISA, we can create ELISA for this one, ELISA for this one, ELISA for this one, like this. So that is this, ELISA up to this one. How many of them? 7. For ELISA. Then Jennifer is 7 of them, just like that. And Joyce is 7 of them. It's a combination. Total how many of them? How many tuples? Multiply by number of element, number of tuples, and number of tuples. Like 2 and 2. So it's gonna be 2 by 2, 4. Like that here, 3 times 7. Total 21 tuples will be created through what? Cartesian product. Why Cartesian product is important? Why? Why do we need? Can you guess why do we need Cartesian product?
Selecting that. Selecting that.
Selecting data what? What kind of data do you want to select through this one? Yes? So your information data that you want to access actually separated, segmented. Why? In terms of relational model, we don't want redundant. So we normalize, segmented already. So your data is here, there, everywhere. So when you access such a data, you need to visit this room and this room, this room. How can you do that? This Cartesian product shows the way how to combine separated data into one. So Cartesian product is the basic operation to combine two relations. However, problem is what? Redundant? Yes, definitely redundant, but this is not a physical relation. This is just temporary when you access the data. So it's not a big problem. The problem is too big. Suppose that we have two tables, two relations. One is 1 million and another one is 1,000. How many tuples will be created? 1,000 million. That's really happen in real database. Okay? Cartesian product create too many rows. Sometimes, for example here, actually I want to access what? Employee, female employee and her dependent. Right? I'd like to access such a thing. So how can you find the dependent of each female employee? You need to check social security number of Elisa, 9999-888-777. Do we have matched one over here? No, actually no. Probably you cannot see. Why don't you? I asked for throughout the semester you need to bring the chapter 3 and chapter 7 and 8 handout. Okay? It shows the company database schema. So you need to take a look at that. And Jennifer's social security number is 987654321. Do we have matched one? Yes. This is the dependent of Jennifer. What about this? Joyce. 453, 453, 453. No. To find this one, we need combine two different relations. Then we got 21. Out of 21, only one is matched. So that means female employee name and dependent. This is a Cartesian product. First, combine two relations. Then find the tuple that satisfy the condition. What is the condition? Social security number is the same as employee social security number independent, right? To find the female employee's name and her dependent. So that means that is this one. Then to differentiate this operation from join, we are going to close this side. It looks like what? Is there any special name of this? It's a butterfly, river, whatever. I don't know what name is. But anyway, this symbol is a new operation with condition. This is called join operation. So you probably heard about the join operation. Join operation is the most important operation in relational model. Why? Why is it important? Because we separate all the data to minimize duplication. Then when you access such a data, you should know how to combine. So this join operation shows the way how to combine the relation, how to access the data that are segmented. How can we implement the join operation? First, product, Cartesian product. Then Cartesian product is the first, then condition. This one is called join condition. So join condition is, join is from two relations R and S. We can do this one. Okay? So this is the another binary operation, join operation. So join, we can use this R and S. You need to specify the join condition. In case there is no join condition, what happens?
Very big data.
Very big data, that is Cartesian product. So sometimes, very, very rarely, in real life system, you need to use Cartesian product. Okay? But you should be careful. Sometimes it takes 7 days, really. Okay? Because it's all the combination. It requires huge memory. Because it's a temporary relation, it should be kept in the memory. It takes a long, long time to process. So you should be careful. Sometimes accidentally, you forgot join condition. When you have the many tables, okay, you need to specify all the join condition. But mistake, you can forget one of them. It takes long time. So you need to check your query when you are using the join operation, whether you have all the join condition or not. What is a join condition? Join condition is the common thing. Just intuitively think about. I'd like to access the employee name and their department. Can you find their department name from employee? No. You need to access the employee information and department information. How can you find department information? Using DNO. Mostly, when you are doing join operation, you can use, not every time, but mostly you can use what? Foreign key operation. Foreign key as a join condition. That is the best way, fastest way. Okay, yes?
Can we use the joint condition with the same relation?
In the same, yes, that's a good question. Sometimes employee has the manager and social security number. The manager information a supervisor, social security number and social security number. It's called recursive. Recursive, the relationship. At that time, you can join employee and employee. Right? So you will see such an example later. So that is the join operation. This is another example. So what is the question? We need manager's name. We need to combine each department. So to get the manager's name, where can you decide if an employee is manager one?
From the department.
From the department, which attribute? Manager SSN. Okay? You cannot find any information clue from employee. Employee has only employee information and department number. Then, where you can find the name? Can you get the name, employee's name from the department?
No.
No. It has only social security number, manager social security number. So using the manager social security number, you can go to what?
To
employee. Then you can find the name. 2. Then we can use join operation. We can combine employee and this is the employee and this is department. So first we can do Cartesian product. There might be so many tuples, each and every case. How many employees do we have? For example, 12. Then how many departments? 5. It will be 60. Among them, what we need is manager social security number is the same as what? Social security number in employee. So that is join operation and join condition. For example, 1 is the 333-44555. 333-44555 for research department manager. And this one is the same. These 3 are the matching. That's satisfied with the join condition after Cartesian product. Yes?
Yeah, when we make, let's say that we don't need to make the joint operation. So we will multiply only. So when the employee has an SSN and he's not a manager, it will be none.
So in this case, if you do not specify this join condition, it will be over here. But in case not, I will show you. In case not, for example, let's say this is not. Okay? You cannot compare the data. There should be removed from this result. Because can you compare the null data and what? It's not possible. So for example, we have the competition for the Miss USA. So I make the virtual, the candidate. So using graphic. Does it make sense? Null means does not exist. It's nothing. Nothing means it's not NULL. Okay? So it doesn't make sense to compare existing and non-existing. So which means it cannot be here in case null data. But that's a good question. Sometimes we wanna manage a social security number even though this is not. We will see later. Then in case there are several different kinds of join. In case join condition, if the join condition is equality, equal condition, like the manager social security number is equal to social security number. At that time, the join condition is called equijoin. Equijoin is the most popular one. That means somebody may be curious. Is there any other non-equijoin? Yes. For example, manager social security number is bigger than social security number, or less than, or sometimes any logical operation, any other operation can be used here. Then, how can you select the data? You can just use the Cartesian product and check the condition. SSN is bigger than ESSN. I know that doesn't make sense, but just suppose this is an example, inequality. So you can return all the tuples that satisfy the condition. SSN is bigger than ESSN, something like that. That's not frequently happen. Many of cases in equality condition. Why? Because we are using the foreign key to connect. When we divide two relations into two, one relation into two, we create a foreign key, right?
Yes.
So equijoin is the most popular. Another one is natural join. Sometimes we have, for example, here, we are going to join department information and department location. Okay, then department has D number and department location has D number. Okay, both of them has the D number. At that time, in case there is a common attribute between two when you join, we don't have to specify the join condition. Automatically, we join with what? Common name of attribute. So that is called the equijoin. So in this case, the department join the D number using D number. Both of them has the D number. So we are not going to specify the join condition with the ribbon or the butterfly symbol. Just use asterisk. However, this natural join is not very popular in real life system. When we are using the DBMS system, Oracle Informix DB2, IBS SQL Server, many of them actually do not support natural join. Why?
Because there's a join problem.
Yes, because we have the join operation. We can specify D number is equal to D number. The problem is, so for example, department and DPT location, yes. D number equal to D number. It's the same name. The only problem is we don't know. Is it in the department location or department relation? We don't know because they are the same name. To differentiate, we can use
The name
of relation
Yes.
in advance to the attribute as a prefix. Okay? Relational name, table name, the attribute. Table name, DPT, location, the D number. Yeah? You don't have to use natural join. Okay? We can specify it. So in real life system, the DBMS system, actually we don't need natural join. Natural join actually was proposed by the Dr. E.F. Code when he proposed the relational model. So that is the reason it's included in the textbook. So don't worry too much. Natural join, you can use just normal join, equijoin. Okay. One more binary operation is the division. Division, I'm going to explain it with example. First, retrieve the names of employees. Names of employees who works on all the project where John Smith works on. Can you understand what that means? Retrieve the names of employees. We need a list of employees. Who works on all the project? Who works on all the project that John Smith works on? For example, John Smith works on project A, project B, project C. That's the example. Then we want to find all employees. Employee who works on at least project A, project B, and project C. Can you understand? So at that time, how can we find such a thing? First, we need to find which project John Smith works on. So we got the project name. Okay. Also, before that, we need to find the John Smith information from employee. Then using John Smith information, we can find project list. Okay. Then we need a new operation to get such a data. So, for example, This is all the employee information with the project number. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9 works on 1 and 2. So 1 and 2 and 6, 6, 8, 8, 4, 4, 4 works on 3 and 4, 5, 3, 4, 5, 3 works on 1 and 2. 3, 3, 4, 4, 5, 5, 5 works on 2, 3, 10, 20. And 9, 9, 9, 8, 8, 7, 7 works on 30 and 10. This guy works on 10, 30. And this guy works on 30, 20, and 20. So total 1, 2, 3, 4, 5, 6, 7, 8 employees are returned. Among these 8 employees, we are going to find where John Smith works on which project. Project 1 and project 2. For example, John Smith works on project 1 and project 2. So we are going to find the employee who works on at least same as John Smith.
Yeah.
What about this guy? Yes or no?
Yes.
Yes. Yes. So we are going to return 1, 2, 3, 4, 5, 6, 7, 8, 9. What's this one? What about the next? Only 3? No. What about this guy?
Yes. Yes.
Yes. 4, 5, 3, 4, 5, 3, 4, 5, 3. What about this? No, because there is no 1, project 1. So this is no. What about this? No. 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 So 2 employees are works on the older project where John Smith works on. Then one more thing. We have another employee 111 works on 1, 2, 3. That's it. Works on the same as the John Smith. Yes or no? In this case,
Yes.
yes. At least John Smith works on. So even though there is another project, it will be included. So this operation is called what? Division operation. It looks like divide. Divide this by this. At that time, return of the division is this attribute. So ESSN. Then find all ESSN that include this one. Right hand side. This looks like the division. So let's look at the another example. We are going to divide R by S. First, what is the return attribute? AB divided by A, which means B will be returned. So we are going to find all B that include A1, A2, A3. Can you understand? That is the division. Then B1, B2, B3, B4. We have 4 of them. Then let's check first one. So can it be?
Yes.
Yes.
B1.
Part of yes. A1, A2, A3. So B1. What about B2?
No.
No. There is no A2.
No.
What about B3? No A1. What about B4?
Yes.
Yes. So B1 and B4 are the return of division. That is division. I'm not going to explain the division by definition. It's more complicated. So I explained the division using example. Why? Because in real life system, if you are using the relational database management system, division, you may never ever you saw such a division operation. So division operation is a very expensive operation actually. So most of commercialized software, they didn't include division in their software database. So I never seen the DBMS. that has the division functionality. Then how can we, in case we need to use such a operation, how can you do that? You can use the other operation, combination of the other operation. Okay? So these are the summary of the relational algebra that we have learned so far. So it will take just less than a minute. Select. We can specify the tuple like this using the symbol and condition. Project, we can specify a set of attributes using the type. Also, beta join is a normal join. You don't have to worry about. Equijoin is the equal condition. And we are not going to use the natural join, but natural join is in case join condition is the same name of attribute both sides. And union, we can combine union. You should be careful when you return the union. It should be unique. So no duplicate data. If you want to allow the duplicate data, you can have use union or. Also, you need to think about the type comparability of union, intersection, and difference. What about the Cartesian and join? The type comparability is required for Cartesian product and join? No, they are different. We are not going to merge like the union. We are going to merge like the attribute by attribute. Then find all the combination. That is Cartesian product. And division is kind of the divide, but it's not frequently used. Anything else? Yes, we are.
Difference is minus?
Difference, yes, it's the same thing.
It's minus.
Yeah, minus. Then, one of the benefits of using relational database model is sometimes there are built-in functions that are frequently used, but not in many programming languages. For example, I'd like to retrieve the average GPA for each department, or for each age, for each grade. How can you implement that? First, you need to classify the student by grade. So junior, senior, sophomore, freshman. Then you need to compute what? Average GPA. How can you implement the average GPA? Sum of the GPA divided by, you need to count number of students for each grade. Right? So you can do that. However, it's a tedious job. What if DBMS provides such a functionality? So relational database model supports such a statistical function. What is the example of such a statistical function? Average.
Sum.
Standard deviation. Variance. Maximum. Minimum. Median. Mode. Others. Including count. These are the statistical function. So, but this statistical function is based on what? Group. So we need to make the group. So for each group we can do average, we can do minimum, we can do maximum. That is called aggregate function with grouping. So the relational model supports such a aggregate function. How can we do that? So minimum, maximum, sum, average, count, average, and so on. How can you use? It's a large F. So large F as the symbol, you can put group. It's called the grouping factor. Grouping factor is the left-hand side. For example, average salary by department. So department is the grouping factor. Average GPA by major. At the time, major will be grouping factor. You can put such a grouping factor on left-hand side. Right-hand side is 100. Then relation. This is aggregate function. It's very useful, very, very frequently used. Okay?
Right hand side is the condition. Oh,
This function.
The aggregate function.
So, for example, first, I'd like to retrieve number of employees and average salary for each department, which means what is the grouping factor? Department number, right? Then, what is the aggregate function? Count SSA. Also, average salary of what? Employee. From employee, you can get such information. Right? The problem is, I put the question mark, social security number. In the question, actually, I ask you, for each department, why don't you get the number of employees and average salary? Then, why do you put the social security number? I didn't mention about the social security number.
Because of the count.
When you count the employee, if you specify the sex, or birth date, or address, some of them are not, some of them are duplicated. So we cannot count exact number. Instead, you can use better use key when you count it. Okay? One more thing. A is 1 to none. Then what will be this? 2 or 3 or none or error. So actually this is the question that I asked in the morning class for extra point to be fair with the afternoon class. So this is a homework. So you can reply to me after class. The first 10 students who reply and correct question will get the extra point. At that time, do not guess. You need to justify why is the 2, why is the 3, why is not, and why is the error. Okay? So this is your homework. Then we can get image. We can use the key, there might be no problem because this is not a unit. So we can get the exact number of employee data. So we can get this one, this one, this one. Sometimes I don't like such a long name, we can rename using the row. It's not a big problem. But problem is,